Alright, so today we're going to look at simple example, like the most basic set examples of the union, intersection, and complement rule. Alright, so these are going to be simple set examples. Alright, so example 1, and then example 2 will be a Venn example, which will be the next video. Alright, so we're going to look at some simple sets, which the universal set is the set S. Alright, set S is my universal. It's the numbers 1 through 9. The whole, or integer values 1 through 9. And then A, B, C, and D are all subsets of that. And you look at them, they're all subsets of that universal set S. Alright, so we're going to find the following. We're going to use intersections, complements, and unions, and we're going to find the following. Alright, so find the set. Alright, so remember, math is a language. Alright, we have symbols that you have to be able to recognize in order to solve problems. Alright, so this involves sets C and D. So I'm just looking at set C and D. But they're two different symbols, and they give you vastly different answers. And so you have to recognize the first one is our intersection symbol. It means and, right? The symbol means and. So I want all the elements C and D have in common. Right? That's what I'm looking for with the and statement. Alright, so I'm looking at C and D. C is the numbers 2, 5, and 9. D is the numbers 4 and 7. Do they have any in common? No. Alright, well, no is an answer. It's just a special type of answer. It means they're disjoint, right? The and statement is empty, or no solution, right? So we write the no solution symbol, which means the and statement is empty. Alright, they're disjoint. It's the empty set. Alright, flip it around. The symbol down here, same two sets, so I'm still looking at the set C and D, but now I'm using the other symbol, which is the intersection symbol, alright, or the or symbol. Alright, so we want all elements from C or D, and anything they might have in common. So it's all inclusive. Anything from C can be included, anything from D can be included, and if they shared some elements, they don't, but if they did, those would also be included, but only one time. Alright, so it's all inclusive. Or is all inclusive. So I get everybody from C or everybody from D. Alright, so I get to include 2, 5, 9, or 4 and 7. Alright, so the or statement was all of the numbers in C or D. And so that's the difference between and or. And it's a big difference. One of them was empty, and one of them has 5 different numbers in it. Alright, so do a few more examples. So give me a second while I erase this. Alright, so let's look at... Alright, so this one has 2 symbols in it. Alright, it's got this and symbol and the complement symbol here. And so I'm going to write down, so remember this is and this is not B, right? Not in B. And so I want the elements in set A and that are not from set B. Alright, so what's in common between set A and the elements not in set B? Remember, not in set B, but in the universal. Alright, if you can read that, in the universal. Alright, the universal set S. Alright, so I'm looking at A. Is there anything in set A that is not in set B? Well, 2 is in set A, and it's not in set B. It's for my universal set, not in set B. Alright, 4, however, is in set B, so I don't include 4, right? 6, I do include because it's in A and not in B. 8, I don't include because it is in B. Alright, so there's the set. all of the elements from set A and at the same time are not in set B. Alright, so this one has 3 symbols and a grouping symbol. So grouping symbols work the same way as sets as they do in our numbers. Alright, order of operations still apply. I have to do what's inside the group first and then what's outside the group. Alright, so first inside my group is set A or set D. So I want the elements from set A or set D. Then outside the group, we're going to do and are not in set C. So then and are not from set C. Alright, those are still in my universal set. Alright, I'm actually write it above since I left room above. So up here in the grouping symbols, I'm going to do the group first. Alright, so everything from set A or set D, right? Everything from set A or set D, which basically includes anything in both sets. If they share something in common, I just write it down once. Alright, so first I'm going to write down A, 2, 4, 6, 8. So 6. And then I get to include anybody in D. I already have 4, so I don't include it again, so I get to include just the 7. Alright, and so there's all the numbers that are in A or D, and now I'm going to do the, now I get to do the and not in C. Alright, and that's going to get me my final. So are any of these in my group not in C, right, at the same time, right? That's what the and means. So anything from that group, and it's not in C. Alright, so I look at C, and I pull anything out of this group that's not in C. So 2 is not included because it's in C. 4 is, because it's not in C. 6 is not in C. 8 is not in C. And 7 is not in C. Alright, and so there is my final answer. Alright, there are all of the elements from set A or set D and are not from set C. And a lot of times that is how we'll ask the questions. We tend to do 2 or 3 symbols when we're asking you these types of questions on the quiz and exams. Alright, so that finishes up this. So make sure you practice the one that I've given you to practice, or I've got one on your own. See if you can't find that set where it's, again, I'll kind of help you out. It's the set in the grouping symbols. It's in the set A or not in set B. Alright, that's in the grouping symbols. And then outside of that is and in set C. Alright, remember, find in the group first and then figure out if any of those are shared with group C. Alright, that's to do on your own though, and later again I will post the solutions to this. Alright, example 2. These are sets with letters in it. Alright, so I just sets with numbers. This is simple sets with letters. Alright, so the sets below. Alright, again, S is my universal set. So I picked the word mutiny, M-U-T-I-N-Y. Those are the letters into consideration. I'm only using, instead of using all of my alphabetical letters, I'm only using those letters from the word mutiny. Then A, B, and C are all subsets of that. And if you look at them, they are all subsets. Right? And we're going to find the elements in the following groups. Alright, so the first one lists the elements in, and again, underneath it I'm going to write in words what it is. And see if you can't do this one on your own. Alright, come up with the right answer, at least descriptively. Alright, so I'm going to write the outside the grouping symbols first. So this first little part is from set C, and then that symbol's and then my grouping symbols, and I've got this prime outside, and so I'm going to write the word and outside my group, not from the group set A or set B. Alright, so there's in words what those symbols mean. I want anything from set C and not from the group set A or set B. Alright, so I'm going to find this first. Not from the group set A or set B. Alright, so I'm going to write it right below here. So I'm looking at A and B. Alright, and I want everything from my universal set that is not from A or B. So I'm looking at both A and B, and I'm basically eliminating anything if they show up in one or the other. Alright, so M, I'll start with M. M is not in B, M is not in A, so it's not in A or B. U is in B and A, so that throws out. T is in B, so I throw it out. I is in A, so I throw it out. N is in B, Y is in both, and so M is it. M is the only letter not from set A or set B. Alright, now I've got a C and in set C. Alright, so is there anything from the group M, there's only one letter in that group, that is also in C? So basically what it is M in group C. Well, here's group C. Group C has the N and T, right? Set C has N and T. M is not in C, and so the answer again is no solution, right? There aren't any letters from set C and are not from set A or set B. And so remember, the answer to that is empty or no solution, right? We draw the little no solution. Remember, that's a perfectly fine solution in mathematics. All right? We've eliminated all the possibilities, and so the set that's left over is the empty set. Alright, so I'm going to erase my stuff here so that I'll work on the next one. Alright, so set A. Alright, the answer to this one was empty. Nothing. Alright, now I'm going to do the next one, so part B. Alright, list the elements in. Again, I've got grouping symbols, about 3 things going on. So below it, I'm going to write in words, so I'm going to start with a group. So it's everything from set A, and remember that's the OR symbol, or set C, and then outside of the group, and not in B. Alright, so first I'm going to start with the group, and then I'll take care of the and not in B. Alright, so anything from A or C. So anything from set A or set C. So I get to include everything from these two sets, and if they share anything, I just list the letter down one time. And they don't, they're actually disjoint, so I just list all of the letters from A or C, so U, I, Y from A, and N and T from C. And then I forgot my not over here, and not in B. Alright, so are any of these letters in the group not in B? And that'll be my final answer. Alright, so U, I, Y, N, and T. Are any of those letters not in B, right? And not in B. So anything from that group, and they're not in B. Alright, so now I'm looking at set B, and again, it's a process of elimination. U is in B, so I don't include it. I is not in B, so I is included. Y is in B, so I don't. N is in B, and T is in, and that's it. I is the only letter, right? And we always will narrow it down. Whenever there's a word and, there's always going to be fewer. Alright, and so I is it. I is the only one that is in A or C and not in B. Alright, the next one's a Cartesian product example where we'll list the elements in. Alright, so I'm going to write my set A and C over here so I have them to look at. Alright, so set A was the letters U, I, and Y. Oops. Set C was the letters N and T. Keep hitting my side of my thing here. Alright, there we go. Alright, so remember, when we do a Cartesian product, I pair together the elements from my first set A with the elements from my second set B to get a new set with as a pair. Alright. And so, just noting the Cartesian product, there's 3 from set A, 2 from set C, so I should have 6 pairs altogether. Alright, so U gets paired with everything from C, so I have U paired with N, and U paired with T. Alright, then I gets paired with N, and I gets paired with T. And then Y gets paired with N, and Y gets paired with T. Alright, and there are all 6 new elements in the Cartesian product where I pick something from A and pair it with something from C. Alright, so there's the 6 different possibilities when I do that. Alright, so last one's try it on your own, so try to find this on your own. So again, I'm going to help you out. I'm going to start out with the meaning of it, and then you'll go through and do this on your own, and later I'll post the answer. Alright, so we want all of the elements. Remember, the prime outside means not from the group A and B, right? So I want to figure out, are there any elements not in set A and B? Alright, so this would be where they share in common, and I throw those out. I don't want those. Alright, so that's for you to do. Alright, so that finishes up simple example of union and intersection and complement, finding simple sets, giving a universal set. Alright, so we will stop there. On the next set, we're going to do a Venn diagram case. Or we're still going to stick with union, intersection, and complement, but it's going to come from a Venn diagram type question.